Section 4.1, examples 4A through 4D. Now we're going to take a look at drawing angles in standard position. If you take a look at this figure on the far left, it illustrates when the terminal side ends up being one full revolution, it forms an angle whose radian measure is 2 pi. Okay, now earlier, remember we talked about the fact that pi radians corresponded to 180 degrees. So it makes sense that if you go the entire circle, one revolution, 360 degrees, that is actually 2 pi radians. In the other figures, you see the quadrantal angles formed by 3/4 of a revolution, 3/4 of 2 pi. We say that is 3 pi over 2 radians. Half revolution, that's 1/2 times 2 pi, which equals pi. That's pi radians. A quarter revolution is 1/4 times 2 pi, so that'd be what? 2 pi over 4. 2 over 4 is the same as 1/2, or pi over 2 radians. Okay, so in example 4A, we're asked to draw and label this angle in standard position. Theta equals negative pi over 4. Well, we know a full revolution, is 2 pi, but what part of a full revolution am I going? 2 pi times what is going to give me the absolute value of negative pi over 4? Well, the absolute value of negative pi over 4 is really just pi over 4. Now, do you see that you have pi on both sides? So to make life a whole lot easier, let's just cancel that out. So really, 2x equals 1/4. Now you might say, oh, divide both sides by 2. But using mental math, it might be sort of hard for you to do 1/4 divided by 2. We also say you can multiply both sides by the reciprocal of 2, which is 1/2. And that's what we're going to do on all these. The equation's always going to be the same. So we're essentially every time going to cancel the pi's on both sides and then multiply both sides by 1/2. So I end up with x equals 1/8, which means an angle of negative pi over 4, you rotate clockwise 1/8. So about 1/8. I know this is not perfect, sorry. And that's my terminal side, that blue arrow that I just sketched there. So that would be an angle in radians of negative pi over 4. So in 4B, we're drawing and labeling the angle in standard position. Alpha equals 3 pi over 4. On example 4A, I showed you the whole way to work it out, but now we've realized there's a little bit of a shortcut. Every time we're just going to say 1/2 times, and we can lose the pi, 3 over 4, we get 3/8. So this means this is 3/8 of the way around the circle, 3/8 of a full revolution. Now because the angle is positive, we need to go in a counterclockwise manner. 3/8, well 4/8 is a half, so it's not quite half. So you see the initial side is the green arrow, and so 3/8 might be about here, and the blue represents the terminal side of the angle. Okay, example 4C, we're asked to draw and label the angle in standard position. Beta equals negative 7 pi over 4. Our shortcut, we're just going to take 1/2 and multiply that times 7/4. And we get 7/8. So to draw this angle, since it's negative, I'm going to clockwise manner. And I go 7/8 of the way around the circle. Okay, so we're going to go clockwise 7/8 of the way. So this is 2/8, 4/8, 6/8, that's about 7/8 of the way. And the terminal side, oh, I'll sketch in black this time. And that would be what the angle would look like. Okay, last but not least, we're asked to draw and label this angle that ends up being 13 pi over 4. Since the angle is positive, that means I'm rotating the counterclockwise position. Now, our little shortcut says, I'm just going to say 1/2 times 13 over 4, and I get 13 over 8. Okay, so starting from my initial side, now you're like, wait a second, Miss People, 13/8? I know. Well, that's going to be 1 revolution is 8/8, right? And then we've got 10/8, 11, 12/8, about 13/8 right there. And I've drawn a red arrow to indicate the terminal side. So this is how we would draw and label an angle in standard position that is 13 pi over 4.